Hello, I'm Tina Oelke, your instructor for PSYC263. Today we're going to discuss Chapter 2 of Lifespan Development, Chromosomal Abnormalities and Gene-Linked Abnormalities. The first thing that you might find handy to do is to print off the PowerPoint, which you can find on the Resources page in the classroom. If you navigate to the Resources page, you'll see under the Chapter Resources heading that there are hyperlinks that say Chapter 2. One contains a set of full PowerPoints for the chapter, and one is an abbreviated version that is just for this audio lesson. If you click on the blue hyperlink that says Chapter 2 Audio, that will bring up the correct PowerPoint. Once it opens, you can then set your print options. I suggest setting it to Notes. You can do this by clicking on Full Slide Page and 3 slides. This changes it to a Notes view. I also suggest printing it in black and white. And if you have a computer that can change it to two-sided, I would suggest doing that. During today's lesson, on our schedule, we will be defining chromosomal abnormalities and gene-linked abnormalities. Abnormalities of the chromosomes are a major cause of serious developmental problems. Most chromosomal defects usually involve the sperm and ovum lacking a normal set of 23 chromosomes. Down syndrome is the most common chromosomal disorder, occurring in 1 in 770 live births, which is caused by an extra chromosome 21. The consequences of Down syndrome include mental retardation, memory and speech problems, limited vocabulary, and slow development. Affected individuals also have distinct physical features, such as a short, stocky build, a flattened face, protruding tongue, and almond-shaped eyes. Sex-linked abnormalities are often not recognized until adolescence when puberty doesn't start on time. These abnormalities involve the presence of an extra X or Y chromosome, or the absence of one. Examples of sex-linked abnormalities include Klinefelter syndrome, which occurs in males born with XXY instead of XY. It occurs in 1 in 600 babies. Affected individuals can have underdeveloped testes, enlarged breasts, and be above average height. Fragile X syndrome occurs more often in males than in females. This happens when the X chromosome breaks off. The consequences of Fragile X include mental deficiency. Turner syndrome occurs when females are born with XO rather than XX, sometimes causing infertility. This occurs in 1 in 2,500 births. Affected individuals have short, webbed necks, trouble with spatial relationships, in that they have trouble drawing pictures or telling left from right, and difficulty in math. XYY syndrome occurs in males with an extra Y chromosome. It was once believed that males born with XYY were aggressive and violent. However, this has been disproven. Gene-linked abnormalities are caused by harmful genes. PKU is caused by an inability to metabolize the amino acid contained in many proteins. It can cause severe damage to the central nervous system in the first year of life. If untreated, it can cause mental retardation and hyperactivity. Sickle cell anemia is a condition where abnormal sickling of red blood cells causes oxygen deprivation, pain, swelling, and tissue damage. Anemia and susceptibility to infections, especially pneumonia, occur. Other abnormalities include cystic fibrosis, where the lungs, liver, and pancreas secrete large amounts of thick mucus, leading to breathing and digestive problems. Diabetes, where the body does not produce enough insulin, which leads to abnormal metabolism of sugar. Huntington disease, where central nervous system Degeneration leads to muscular coordination difficulties, mental deterioration, and personality changes, and Tay-Sachs disease, where the central nervous system degenerates and leads to poor muscle tone, blindness, deafness, and convulsions. Every individual carries DNA variations, but most do not display a disorder. Today, most genetic disorders can be found prior to and right after birth through a variety of testing. However, as through the video clip we will watch next, sometimes having knowledge leads to difficult choices. Let's watch a video clip together about the pros and cons of genetic testing.
What kind of species do we want to be? What kind of society do we want to build?
There's an overwhelming likelihood, a huge likelihood, that everything is fine with the baby. But there is an increased chance that there's a problem.
So what if this baby has some sort of genetic problem? We'll deal with that.
It is absolutely arrogant for me, I think, to say to a parent, I'm a dwarf, you better keep that dwarf kid.
I don't want to live in a society that tells me what kind of children I can or can't have.
Funding for Our Genes, Our Choices has been provided by the Robert Wood Johnson Foundation, the National Science Foundation, America's Investment in the Future, the Alfred P. Sloan Foundation, the United States Department of Energy Office of Science, and the Josiah Macy Jr. Foundation.
I'm Robert Krulwich, ABC News. This is Eric Lander, professor at MIT and at the Whitehead Institute. Let's suppose my wife and I discover we're going to have a baby.
Congratulations.
Well, thank you very much. And so we go to the doctor, and he gives us, says just genetic testing. We say, okay. And then he comes back and he says, we've turned up some abnormalities. So I hear abnormalities, and right away I'm thinking, oh my God, genes are destiny, like some terrible curse, like a lightning bolt. And one day, this gene, whatever it is going to kick in, and my baby will be shorter or sicker or slower than all the other children. It's fated now. It's in her genes. You recognize this situation.
People often think this way.
Now let me ask you, I'm going to make it easier. I'm going to give you my baby.
Oh, nice to meet you, baby.
She made a little comment.
That's a cutie, yeah.
Now, when you hear the phrase bad gene, do you hear inevitable disease, destiny, or do you hear maybe, possibly?
Well, there are a small number of things that are destiny, a small number of genetic certainties where you can say the baby, God forbid, is going to have some terrible disease that we can't do anything about. But most of the genetic information that's encoded in the human DNA is not about certainty. It's about the fact that perhaps when she grows up, she'll have twice the risk of diabetes. That's not good, but it's not a disaster. I think as a parent that you have to add this long list of maybes that genetics is going to potentially give you to a much longer list of worries that every parent has had since there were parents.
Like what?
Is your child going to grow up happy? Are they going to marry well or marry unhappy and get divorced? Are they going to have an unsatisfying career? Are they going to get hit by a bus?
So then against that string of maybes, maybe the bad bus, maybe the bad husband, you just add another string of maybes.
I think that's largely what it is. And if anything, there may be some maybes that maybe we can do something about. If you know you're at risk for diabetes, you might be able to do something about it in the future.
And knowing then that we're going to live in a world where there's a much longer list of maybes, not certainties, we're now ready to consider some of the surprising problems that might arise, which means we are now ready for my friend and NBC correspondent John Hockenberry and his friend-friendly seminar panelists.
Let's meet Lee and Meredith. And Adrian. Adrian is a friend of Meredith. Lee and Meredith are a married couple who are going to have a child, and we're thrilled. Adrian particularly is thrilled about that. First child, as someone who's 35, you're going to have amniocentesis. You're going to get tested. It's something to do just to be on the safe side for women who are 35 years old. Adrian, a conversation develops around the test and around this joyful event in this family. What's the conversation?
Well, I think it's great that you're pregnant. I don't necessarily know why you want to get tested.
Well, I've been told I should get tested, actually, because I'm 35 and there are all these questions. I have the same doubts in my mind because I've had miscarriages, 3 of them coming into this. So I'm a little hesitant, but my husband felt it was important that we have the test.
I thought it was very important to have the test because it's clear that at this age, as you know, there's a higher risk of having an extra chromosome in the fetus that could bring about Down syndrome.
There's a whole lot of things that they can test for. Adrian,
all right, I've known you a long time. You want to have a child. Well, so what difference does it make what your child is?
Well, I mean, in theory, I guess it doesn't make a difference. Obviously, I want a baby desperately. But because of that, would I allow myself to give birth to a baby that may have tremendous trouble to satisfy some need in me and not really caring about the baby? That's the dilemma I'm in. I think that's why I agreed to go through with the amnio, even though I don't know how to process the information if it's not good. I don't know whether I'm thinking for myself in selfish terms or whether I'm really thinking about this baby.
It's a fact that some children are born with health problems. And if we can avoid those problems, I think that would be best for the child.
Well, I mean, you can't make any conditional statement about what's best for a child. Health problems are only one kind of thing that people have.
I would agree with you completely. But for example, I'm an asthmatic. There's nothing positive about being an asthmatic. If I could make sure that
I love
my
you. You
son
wheeze all the time.
That's right. And, you know, I have to take medicine every day and night. And if I could have a daughter or son that didn't have to depend upon medicine to stay in good health, I think everybody would agree that's a positive.
But I think because you're an asthmatic, you're more sensitive about this. And I look at it from the other side. So what if you're asthmatic? So what if this baby has some sort of genetic problem? We'll deal with that.
Of course, if the child is here, of course we would deal with it. We would love the child. But if we can avoid this problem
what do you mean
time,
when you say avoid this problem? That's a euphemism for what?
Well, a euphemism for if in the case of a amniocentesis diagnosis, if it was possible to identify genes that predispose the child towards asthma, then we would have to make a decision of whether to abort. I don't think I would abort.
So avoid this problem is abort, try again.
Yes. I think asthma is not a serious enough condition to abort. I would want to have the child. The child can use medicine and lead a normal life.
So what's the difference between asthma and Down syndrome, in your view?
Well, I think there's a difference. I mean, I would agree with my husband on that, but I'm not sure if that's still reason to abort. I mean, we have a nephew who has Downs, and every Christmas we go to visit, and I watch him. He's now 12, and I see his mother still treating him as if he's 2, because that's really developmentally as far as he's ever going to go. And I think sometimes I hate myself for thinking about it. I look at her and go, I wouldn't want her life. I wouldn't want that. And I look at this little boy and I think, what quality of life does he have? Then I'm not sure whether it's fair to bring this child into the world.
Is that their right, Adrian?
Oh, it's certainly their right. I'm not sure it's a very terrific attitude to have about being a prospective parent, because if you work so hard to avoid whatever set of characteristics, how do you really know in your heart that you'll deal with the surprises that any child is going to give you?
Well, then why'd they come up with the stupid test in the first place? Because all this does is provoke anxiety.
Well, Mr. Miller, you're friends of Meredith and Lee.
Well, I can understand your anxiety about that. Ultimately, it's your call, and your very personal and difficult call, what to do. But I guess the question that I wonder if you would ask your nephew is, would he rather be living his life and be here than never have been born at all?
Are you advising them to take the test and worry about all that later, or are you suggesting they perhaps even avoid it?
I'm suggesting what I would think is not to take the test lightly, because the test is going to give you information that's going to force you to make a decision one way or the other. And even not acting is making it.
In conclusion, the answer of genetic testing isn't an easy one, and certainly one I'm sure that opinions will vary on. Behavior and genetics are linked with genetic loading. How much the environment plays on it is complex. Much more development and research needs to be done. This concludes what we will be covering in our PowerPoint mini lesson. The reflective log assignment asks you to suggest ideas for future research designed to advance knowledge on the concepts in the chapter, or apply the material learned in the chapter to a current news issue or to experiences in your own life. I suggest that you not only consider the concepts that you heard on this presentation, but also what you have learned in the rest of the chapter. Some interesting things to reflect upon would be ethical considerations of genetic testing and withholding information from parents. What prenatal information is useful to parents? What prenatal genetic information, if any, should be withheld from parents? What areas would you like to see research done in biological beginnings? What have you seen done in the news recently that you'd like to comment on? There are a lot of ideas out there from Chapter 2. Have fun! I can't wait to read your logs.